Okay, today we're in section 5.2, adding and subtracting like fractions. So the word like is important. What does it mean to be a like fraction? Okay, say very good. Same denominator, same denominator. So in example 1, it says 77 out of 100, 77 hundredths of the moon's visible surface is illuminated. The next night, an additional 9 hundredths is illuminated. So what fraction of the moon's visible surface is illuminated? All right, so we take night 1 and we add it to night 2 and we reduce the fraction. So reducing fractions is a really important concept over the next several sections. And then also checking for common denominators. That's very important also, which thankfully in this section we don't have to worry about. All right, now we also need to look at just some other scenarios that we might kind of come across, whether it's in a homework section or on a quiz or on a test. All right, number 1, it's pretty straightforward. 3/8 plus 2/8. I do just check real quick. Same denominator, yes. So I only add the numerators. Remember, the denominator just gets brought over. Okay? Number 2, I see integers coming into play where I have a negative integer and a positive, so I have to apply my rules. Different signs, subtract and take. So 5 minus 1 is 4, and I keep the sign of 5 because 5 is bigger and 5 is positive. So it's going to be 4/6, and I reduce it. All right, so just using our rules for positive and negative numbers. On number 3, though, what's 12 plus 8? 20. So if I get 20 over 19, what do I call that? An improper fraction, and I cannot have an improper fraction in my answer. So I need to ask myself, how many times would 19 go into 20? 1 with how many left over? 1 left over, so 1 and 1/19. Okay, so just converting between improper and mixed numbers, that's really important too. Number 4, I need to decide if this is same sign or different. Well, I don't really like seeing the plus and negative. Remember, we try to get rid of those double signs. That's the same thing as just subtracting it. So if I have a negative 21 and a negative 15, okay, same sign, add and keep to make negative 36. Is that my final answer? No, because why? Why isn't that my final answer? It's improper. So 26 goes into 36 how many times? 1 with how many left over? 10 over 26. But again, that's not my final answer because I can still reduce. So I just keep reducing until I get to my simplified answer. All right, on your homework, some of these problems will require work, some won't. I would want to see the 20 over 19 showing that you added and then converted. Your improper fraction, again, that you converted. But notice on number 1, is there really any work to show? No, I mean, we're just adding them together. So it's not that you'll be deducted if you don't have any work on a problem, but while your calculators are permissible, you're allowed to use them, you shouldn't use them to basically skip over steps that you need to be learning, okay? Which, for example, would be the 12 plus 8 is 20, because you need to understand how I got to the mixed number. How did I get one whole? Well, I can see that I could take 1 out of 19, or 19 out of 20, and leave 1 left over, all right? So that's just the important part for that. All right, now in example 2, it's subtracting fractions, subtracting like fractions. So the good news is this is really the same rules. It doesn't matter if I'm adding or subtracting, it still goes by same sign, add and keep, different sign, subtract and take. And then I use my rules for double signs. So on the first one, negative 4 over 7 minus 2 over 7. Well, what's negative 4 minus 2? Negative 6 over 7. Remember, I keep my common denominator every year without fail. Once we kind of mix everything in together, I have people on the test add their denominators and subtract their denominators. It happens every year because we start to get our rules confused. So just remember, when I'm adding and subtracting fractions, I just keep my common denominator in my answer. What do you see on the second one? You see a double negative, okay? So cancel that into a positive, and you get 4/10, which reduces to 2/5. All right, now we had 3 other ones that we wanted to solve. And again, these are just reinforcing some of the scenarios that you might see on homework, quiz, and test. All right, 2 minus 7, that's kind of an odd way to write it, but I can still solve that. What is 2 minus 7?
Negative.
Yes, it's going to be negative 5 over 15, which reduces to negative 1/3. Okay, now on the next one, what do you see there on number 2? A double negative. All right, so you add them together now and reduce. Okay, so if you don't catch the double negative, you're probably going to miss the answer, right? Because you're not going to know to add. Well, number 3, is that same sign or different?
Different.
Wait, 6 is negative, 12 is negative. So that's a subtraction sign. Well, it's the same thing. That's still negative. If you're subtracting something, you're taking it away, right? So negative 16 minus 12 is negative 18 over 17. Well, what is that? What do I call negative 18 over 17? I call it an improper fraction. So I need to convert it. 17 goes into 18 one time with 1 left over, and I bring over my negative. All right? So that's examples 1 and 2. We're just kind of going through this addition and subtraction and all of our rules. Well, in example 3, now I'm just going to throw in mixed numbers into the mix, if you will. Okay, so now these are mixed numbers. Well, here's what our rule says. Our rule says to change them first to improper fractions. And I would agree with that. Even though you could just add these straight across, there are several things that you would run into. For example, carrying over and then needing to add one more to your whole number. When you're having to find common denominators, it just makes everything more complicated if you are dealing with mixed numbers. So here's the rule we're going to go by just across the board. When we see a mixed number, we're going to convert it to an improper fraction. Okay? Always. Addition, subtraction, multiplication, division. Across the board, when we see a mixed number, we're going to change it to an improper fraction. So go ahead and change those first 2 fractions or mixed numbers to improper fractions. All right, so I convert. I get 50 over 9 and 25 over 9 to make 75 over 9. Now, we could probably convert this one pretty easily back to a mixed number, but I want to show you how to do it on your calculator. All right, now, when I say this, I do still want to see the improper fractions in your work on your homework. So even though you can use your calculator, that doesn't mean just put these in and spit out an answer. There's still work to show, but now we can use our calculator, that's fine, to convert it at the end. Does that make sense, guys? You understand when you can use it, when not? So now, once you hit equals, it reduces it for you. Did you do that? Okay, now hit Shift and hit the S to D button. Shift and then S to D. Do you see the mixed number? Okay, what does it say? 8 1/3. Okay, and that's fine. 8 1/3. And that's my answer. So on the second one, we convert to improper fractions. Then we simplify. Okay, and now we have our improper fraction that we can put in our calculator. Negative 222 over 13. Don't forget the negative. Shift S to D, and we get 17 1/13. Okay, and remember to bring over your negative. All right, so just the mixed numbers, guys, I want you to remember you need to change to improper and then convert it at the end. Okay? All right, so now moving on to example 4. This is our simplifying variable expressions. We're going to do 4 of these. Okay, so now we're going to see variables come into the mix. Okay, where we now have to use our rules for adding and subtracting variables. Okay, well, when it's in the numerator, that's really no big deal. Remember, 3a plus 5a does not mean to add the exponents. That just means that there are like terms. There are like terms that we can add together. So 3a plus 5a would be what?
8A.
It would be 8a. And then can I reduce that?
Yes.
Yeah, I can. I can reduce those numbers. 2a over 5. All right, so that's really no big deal. The complicated part of variable expressions we're actually going to see in 5.3, where we have to find a common denominator with variables. All right, we did a touch of that back in, might have even been chapter 3, goodness. Maybe chapter 4, earlier in chapter 4. But nonetheless, okay, we're going to see some of that, but not until 5.3. So here, thankfully, we do have common denominators. So now we're going to look at our numerators and focus there. Well, what do you see kind of jumping out at you? What do you see? You see that double negative. That's got to change to a positive. And negative 8 plus 2 is negative 6. Well, this is going to be kind of interesting because I know I do need to reduce, right? What ends up being in my numerator?
2 over 1b. Negative 2.
Negative 2 over 1b. And technically, do you need the 1?
No.
No, you could just leave it. Okay, so negative 2 over b. Think you can do a couple? Okay. All right, so let's try. I'm going to have you do these 2 on your own, and then we are going to go over it. 5c plus 4c is what?
9c.
It's just 9c. Okay, remember, like terms, so I'm just going to add and then keep my common variable. 9c over 13, nothing to reduce. On the second one, I have a double negative. So what's negative 7 plus 2?
Negative 5.
Negative 5 over 11x. These I don't even reduce, okay? They're already in simplest form. So just different types of scenarios you might see on your homework assignment tonight. Here's our main thing that we need to remember. Remember your signs, your rule for your signs, okay? Your positive and negative numbers. Calculators can help, but I do need to see some of that work. Changing mixed numbers to improper fractions, showing the answer before you reduce, that type of thing, okay? All right, so just practicing some of those skills. And if you understand that, it's everything you need to know for section 5.2.